Hello world, what is going on? It's good to see you back here on the channel, and today we'll be looking at the third exercise of Codility lesson 3, Time Complexity, which is called TapeEquilibrium, and we'll see how to use summations to avoid taking the naive approach, which would be iterating over slots that we have already calculated. So let's get at it. Okay, so as always, let's get into the Codility page, lesson 3, Time Complexity. Let's go ahead and check TapeEquilibrium. Let's select Python here. And it says, a non-empty array A consisting of n integers is given. Array A represents numbers on a tape. Any integer p such that p is between 0 and n, split this tape into two non-empty parts, from a0 to ap-1 and from ap to a at n-1, where n is the length of a. The difference between the two parts is the value of, and we have a mathematical expression here which says that we need to subtract from the first part the second part and get the absolute value of that, where the first part is the summation from a0 to a at p-1, and the second part is the summation from ap at an-1. So pretty much what they're saying is split the tape in two and subtract the second part from the first part. In other words, it's the absolute difference between the sum of the first part and the sum of the second part. For example, consider array A such that 3, 1, 2, 4, 3, and we can split this tape into 4 places at p1, 2, 3, and 4, and when we calculate the absolute value of the difference between the first part and the second part, we get these numbers here, 7, 5, 1, and 7. So write a function that, given a non-empty array A of n integers, return the minimal difference that can be achieved. So in the example given above, the function should return 1. So write an efficient algorithm for the following assumptions. N is an integer within the range 2 to 100,000, and each element of array A is an integer within the range minus 1,000 and 1,000. So if we look at the upper limit here for n is 100,000, which is 10 to the 5, and if we take the naive approach, which would be summate all the elements on the left and on the right for each division of p, where that solution would run on n squared, and 10 to the 5 to the square, it's 10 to the 10, which is way more than 10 to the 8, so that won't run in an acceptable time. So let's go ahead and understand graphically what this exercise is about. Okay, so we have here the array in the example, and we are going to divide it. This red line is going to be p, and we're going to divide it at each position, and we're going to add what's on the left part and add what's on the right part, and subtract the right from the left and get the absolute value of that. So the idea here is that we're going to calculate this maximum, or not maximum, but the summation of everything that's on the right, and we are going to subtract for each iteration what's on the left side as we iterate over this left array. So let's go ahead and code this in Codility. Okay, so we're back here in Codility. Let's go ahead and click start the test. We're going to select Python here. Let's clean this out. Okay, so the first thing we have to do is calculate or assign what's on the left to begin with, which is the first element of the array, what is going to be our summation. So we're gonna say sum of a from the first element, excluding for the second element to the end, and we're going to say that the first difference is going to be the absolute value of left minus right. Right, now we're going to divide everything into the p divisions. So for p in range 1 to length of a, we're going to calculate this new difference, which is going to be what's on the left side minus the right, and we're going to calculate the absolute value of that. And then we need to ask if this new difference is smaller than the difference we already have, then we are going to reassign the difference that we already have, and then we are going to start building up what's on the left side. So on the left, we are going to add A at P, and from the right side, where we are going to remove or subtract what's on A at P. And finally, we just need to return the difference, which will be the smallest difference that we have found so far. Let's go ahead and run this. It seems to be running fine. Let's go ahead and submit the task. And we have the results back. We can see here that we had a 100% task score and correctness score, and it works on ON, which is not the naive approach, which would be ON square, and everything looks fine here. Okay, so that was it for this exercise. We saw how to use a simple summation to avoid taking the naive approach, which would be iterating over all the p's that we have already encountered and summing or adding them again, which is not efficient at all. That would be an ON square solution. And we got our exercise at ON, which is great. So that's it for this exercise. If you like the video, please hit the like button, subscribe to the channel, and share it with someone if you think it would be valuable for them. I'll see you in the next video. Bye.